All right, when we study each equation in its graph, how does the a value affect the parabola? In the first graph, the a value is 1. We should notice from the origin, if we go right 1 and up 1, we'll get to our first point. To the next graph, the a value is 2. We should notice that the graph has gotten skinnier as it goes up. And then from the origin, it goes right 1 and up 2 to get to its first whole point. When the a value is 3, it has gotten even more skinnier, or it has stretched vertically. And in this example, when the a value is 3, it has gone right 1 and up 3 to the next whole point. In the last graph, you should notice that a negative a value will flip the graph. Again, the negative 4 still holds true. If I go right 1 and down 4, that's how I get to my first point. We're going to use these observations to graph from different forms now. So on number 2, we are in vertex form. So I'm going to pull the vertex out. So the vertex should be at 1, negative 4, because this would move it right 1. And it would move it down 4 from the origin. So I'm going to start by plotting that point. Now my a value is 2. So to get to my next point, I'm going to go right 1 and up 1, 2. I'm going to go left 1 and go up 1, 2. Here is the sketch of my parabola.
Amaya Berry to the attendant.
Now the next one is in standard form. So in standard form, we need to find the vertex. And in yesterday's quick notes, we wrote down that to find the x value of the vertex from standard form, we're going to do opposite of our b value divided by 2a. So I'm going to pull out my b value and my a value. And I get the x value is negative 1. And again, this is just the first part of my vertex. Now I need to find my y value. I'm going to use the equation. I'm going to replace x with negative 1 and simplify. We should simplify it to b2. So here's my vertex point. Is negative 1 up 2. Here's my vertex. Now the a value is 3, and it's also negative, so I'm going to go right 1, down 1, 2, 3, or left 1. Now I'll go right 1 and go down 1, 2, 3. And it's opening down because the a value is negative. So that's an example from standard form. Our last one is going to be factored form. Please pause and stop this video as needed if you need a minute to write things down. So the next one's in factored form. And for factored form, we would set each factor equal to 0 and solve for the x-intercepts. This is what we talked about in our last unit. So I know my two x-intercepts. Now that I know my two x-intercepts, we'll graph them. So my first x-intercept is at positive 1. My next one's at 3. Remember, your axis of symmetry, AOS, is right in the middle of those two values. So it's at 2. The axis of symmetry also tells you your x value of your vertex. So now I know the x value of my vertex and I'm going to plug it into my function. Once you have the x value is 2, you're going to plug it back in to the factored form equation and simplify for the y. Again, this is timesing because it's in factored form. So I'm going to get the y value as positive 2 also. And now I'm going to graph that. And it's opening down, which makes sense because our a value is negative 2. Again, if you need to pause and stop and start this video, you can do that. We're going to move on to the quick notes. In the quick notes, we really just talked about these steps. Okay, so this is for graphing. When a does not equal 1. Here are the 3 forms we'll look at. So in vertex form, you're going to identify your vertex. Then you're going to use your a value to move to 2 other points, like we did in the example. In factored form, you're going to find your x-intercepts. You're going to find your axis of symmetry. That's your x value. So then you're going to plug it all in to find your vertex. Standard form is a little different. For standard form, we've got this equation to find the x value of your vertex. It's opposite of your b value, all divided by 2a. That'll tell you the x value of your vertex. Then you're going to plug that in and find the y value of your vertex. And once you have the full point, you'll graph from there. And again, use your a value to move to 2 points left and right of that vertex.